Okay, let's work a magnitude problem. And here we are looking at the fall-winter night sky. We're going to look at a star called Nath. And Nath is an interesting star. It's got a magnitude of about 1.65, and it's this little star here in Taurus. You kind of go up here. Here's Taurus. That's V. There's the V of Taurus, and let's go up to Nath. You follow the top arm up to that star right there. That's Nath right there. And if you look carefully, you can see that it's about the same brightness as Bellatrix down here. Here's Bellatrix. Both of them are about 1.6 magnitudes. That's apparent magnitude. Dimmer than, say, Rigel, which is this one right down here. Brighter than, say, this little star right here, which is 3.4. So it's a fairly bright star. And let's say we also know the absolute magnitude of Nath. And Nath is N-A-T-H. Absolute magnitude of Nath is minus 3.2. Okay? So the absolute magnitude, capital M, is minus 3.2. So if we know those things, I want to find the distance to that star. What's the distance to Nath? And so let's think about that. And the first thing you have to do is stop and think about what equation you'd know. So if you have a question that involves an apparent magnitude, which I just said was about 1.6, it's actually 1.65, and an absolute magnitude, and in that case it's minus 3.2, and it asks for what's the distance. We want to know that. Which equation has got an apparent magnitude, an absolute magnitude, and a distance? That's the first thing you have to ask. And the way you look at that is remember that the equation m minus big M is equal to 5 log d minus 5. That's got to be the equation we know. And then you start off by saying, well, what do I know and what do I not know? Check mark above what you know those two things, and clearly what you don't know is d. That's the unknown. So let's go ahead and solve for it. And the first thing you have to do is add 5 to each side, so that you're going to have little m minus big M plus 5 is going to be equal to 5 log d, and then you divide each side by 5. So we're going to, in the end, have little m minus big M plus 5. The whole thing divided by 5 is going to be equal to log d. And now we're pretty much done. Let's go ahead and stick the numbers in that. We've got 1.65 minus 3.2 plus 5 divided by 5. What's that going to be equal to? Well, 1.65 minus a minus 3.2, that's the same as adding 3.2 to 1.65, and that's going to give us 4.95 plus 5 divided by 5. What's that's about 5 plus 5, that's about 10. So it'll be a little bit less than 10 divided by 5. It'll be a little bit less than 2. And that means that 2 is equal to the logarithm of d. What would be d? What number d has got a logarithm of 2? And that's easy. You'd think back and you'd say, well, d is going to be about 100, because the logarithm of 100 is going to be 2. It's going to be a little less than, in fact, it's actually 93 parsecs. What does that tell us? Well, if you wanted to know how far it is in light years, you know that parsec times 3.26 tells you the number of light years. So that means that d is going to be equal to about something like 326 light years. So when you go back and look at that little star, light is going to travel from it in about 326 years. If you do this with a little more accuracy, you find that it's actually about 304 light years away from us. So when you look at that star in the sky, follow that V up, and you can always find it by looking at the belt of Orion, drawing a straight line through. That'll point you right to Taurus, and then you follow the top up to Nath. You know that the light has left that star 300 years ago. So it's about the year 1700 and or so, 1711, and that's when the light left there, and it gets to us tonight.